Here, welcome to this video. I hope you're having a nice time. So my aim is to make you good in physics, and this is not the only video you're going to be watching. After now, after you've taken all the old video on this course, you'll be receiving constant and daily updates on how to solve other physics questions. Do we get that? So today we're going to be talking about heat and thermodynamics. So the essence of this course is to teach you how to solve critically related questions wherever you meet them, maybe CBT or ICT questions like computer-based tests, you understand, or written examination. And most times horror case could come. So today we're going to be talking about heat and thermodynamics. What do you understand by heat? We most times we feel a difference in temperature, heat. So that is why they created air conditioning. Do you understand? And most times when the cold is too much, they create something we call warmer. I believe you know what warmer is. Do you understand? So this is a practical physics topic that relates to real life situations. So here's what I want you to know about this. Heat energy is the energy transferred from a hot object to a what? Cooler object as a result of the difference in temperature. Do you understand that? So you can just take note of that definition. Temperature is the degree of hotness or coldness of the body. Do you understand? So someone is cold and someone is hot. So that's temperature. Do you understand? So there's something called change of state. Change of state. So under change of state, we have something called fusion. Do you understand what fusion? Fusion is a process whereby a substance changes from a solid state to liquid state when heat is applied to heat. Do you understand this? Now listen, this I know, this what I'm kind of reading, I know it. Do you understand? So I'm just reading for you to write it down or jot it somewhere. Do you understand? So you won't forget that. And if you know it, good luck. That's good. So there's something we call vaporization. Now listen to this. Vaporization is the process by which substance changes from a liquid to gaseous state when it is applied to heat. Now vaporization is different from evaporation. Take note of that. Evaporation is a process whereby liquid turns into vapor only and only below its boiling point. So the method of heat transfer, so we have conduction, we have convection, we have radiation. So conduction deals with the solid conductors, you understand. Most times whenever you put a spoon inside a cup of tea, hot tea, as we do take it in the morning with a cool slice of bread, you understand. Most times if you leave it for a while, you notice that the spoon becomes hot. That is the explanation of conduction, where it is transferred into a solid conductor. Do you understand that? By a material medium. Do you understand? So convection is when heat is transferred by the heated medium itself. You can check on that. While radiation is where heat is transferred through an electromagnetic wave. So make an example of some flasks, some vacuum flasks, some silver-based flasks and stuff. But that is not where I'm going to. I'm talking about calculations in physics. Do we understand that? Thank you. So here's another thing I want to know. There's something we call expansitivities in doing it. So whenever it is applied to something, the thing tends to expand. Do you understand? Most times it tends to what? Expand. Take for instance oil, palm oil. When it is applied to palm oil, when you know it expands. So that's just a natural explanation of that. So under expansivity in calculations, we have something we call linear expansivity. Expansivity in length of a substance or a material. Do you understand? So there's something we call area expansivity, expansion in area, and there's something we call cubic expansivity. So let me jot that down. So we have linear expansivity, we have area, and we have volume or cubic. You understand? Cubic expansivity. So let me just kind of write this down. Expansivity. So this is given by alpha. So now linear expansivity is given by alpha. Now listen, beta expansivity or area expansivity, I call it beta. Do you understand? It's kind of given. Let's call it beta. Do you understand? Oh, yeah, beta. And this one is given as gamma. How do you write gamma? I've forgotten. So it could be like this. Do you understand? Or I'm not sure. Or could it be like this? I don't know, any of the two, anyone you want to pick, do you understand? But there's a general stuff, I'll check on that. Permit me, pardon me for doing this, do you understand? So now, alpha, beta is equal to 2 alpha, and gamma is equal to 1, 3 alpha. Do we understand? So you have to know this. Do we understand? Now, for the formula for area expansivity is given as length 2 minus length 1 over length 1 change in temperature. Do you understand? Y for beta is given as 2 alpha is equal to what? Area 2 minus area 1 over area 1 change in temperature. So generally this you can just divide by 2, so you can have beta equal to what? A2 minus A1 over 2A1 change in temperature. So you can have this, and Y gamma or cubic expansive. So then we can then just put cubic. Cubic is given as 3 alpha. So you just kind of divide by 3, you understand? So you have something like 3 alpha towards volume 2 minus volume 1 over volume 1. Change in what? Temperature divided by 3. So you can have alpha. So let's put gamma. So you go V2 minus V1 over what? V3 V1 change in theta. So you should just know this. Just have this in mind. Do you understand that? So whenever you say something V2 minus V1, A2 minus A1, this and minus this is what we call change. So it's given as this. So you can literally write L2 minus L1 as what? Change in length. You can have A2 minus A1 as change in what? Area, and V2 minus V1 as change in volume. So all those things are just the basis of what I just want you to know about that. So before we proceed, there's something I would like to teach you guys about standard form, where most times people make mistake. Standard form and conversion to Kelvin, degree Celsius and stuff. So we're going to be doing that. Spare me a minute. Okay, so I don't really need to go that far. I just kind of continue from here. Do you understand that? So now on the standard form, to convert some stuff to standard form, this is what we're talking about. So you can have 0.123418. Do you understand? This counts to convert this to standard form, and you can also convert this one from standard form back to a normal number. Do you understand? So to convert from standard form, you have been taught in secondary school, you count the number, especially this kind of stuff. Okay, let me add one more, like this 18, 1, 2, 3, 4, 5, 6. So we want to convert this to standard form. So to convert these kind of questions to standard form, are you paying attention? Because we're going to be seeing more of this in physics. There are more to the understand. So convert this to standard form, you count the number of times the decimal moves to a number after the 0. This is what I'm saying. So let's count. This is 1, 2, 3, 4, 5. So you're gonna have something like 1.8 times 10 to the power minus 5. Whenever it's going this way, it will be minus 5. Whenever it's going this way, it will be 1 plus 5. So to convert this to standard form, there's an invisible 0 at the back here. So you're gonna count the number of times it moves to a number before the 0. This is what I'm saying. So we have this 1, 2, 3, 4, 5, 6, 7. So we have something like 1.8 times 10 to the power 7. Why is this 7 and why is this minus 5? Whenever you come this way, it's going to be minus. Whenever you go this way, it's going to be plus. You understand? So we call this the A. We call this the N, the power, an integer. It could be any integer. You understand? So standard form is given at A multiplied by 10. That's about N. Okay. Let me write it properly. A times 10 to the power N. So in mathematics, you should know this. You understand? But that's not my N. You understand? So and something else I want you to know. Converting from degree Celsius to Kelvin. So whenever you convert from degree Celsius to Kelvin, you had 273. Do you understand that? All pay attention. So whenever you convert from Kelvin to degree Celsius, you minus 273. Kelvin. Do you understand? So it's like this to this, you had 273 Kelvin. This to this, you must minus 273 Kelvin. So I believe you just know the basis of this. So let's just kind of solve practical related questions to this. Do we understand? Thank you. I'm coming. Okay, so I'll have to clean this so we're able to find space to solve question related to this. Okay. So number one question, they asked me, said a copper whose length is 30 degrees Celsius is 10.0 meter. Please avoid distraction. I'm sorry for the disturbance. So a copper rod whose length is 30 degrees Celsius is 10.0 meter is heated to 50 degrees Celsius. Find its new length. Take alpha for copper at 0.00017 Kelvin inverse. Now, I told you something. Whenever I say some kind of physics question, you'll bring out the parameter, you convert them if necessary, apply the formula, and get the answer. Do you understand? So, in this case, whenever you say something new, that's A2, V2, L2. Do you understand? But if you say original, that's L1, A1, and V1. Can you need to pause for now? Okay, let's just kind of continue. I won't let them waste my time. Do you understand? I don't have time to wait for them. So they ask us to find for the new length. So let's say example 1, G1, solution. I'll pay attention. So they say we find for the new length. They say a couple of those lengths. So this is the theta 1. The first we theta 1. Say L1. They give us L1 as 10.0 meter. Is heated to this is theta 2. That's 50 degrees Celsius. To find the new length, that's L2. Is this? They give us alpha as 0.123417 Kelvin inverse. I'll pay attention. Remember the formula. The formula is given as alpha is equal to what? L2 minus L1 over what? L1 change in what? Theta. But what are the things to find for L2? So if we can do this in two practical terms, I can make L2 a formula, or I can repeat everything and solve everything together. I believe you hear what I'm saying. Just avoid distraction for now. Do you understand that? So let's continue. So we have okay, let me make L2 a simple formula. So cross multiply. So we have alpha L1 L2 minus L1. So let's take to this side. So we have L2 is given as L1 plus alpha L1 change in theta. I'll pay attention. So this is what we're going to use. So we have L2 is this was L1. L1 is what? 10 meter plus. So all this thing is not bracketed. So alpha is what? 0.1234. So it's multiplied by L1 is 10 multiplied by change in temperature. Change in temperature is theta 2 minus theta 1. So let's do theta 2 minus theta 1 is what? 50 degrees Celsius minus 30 degrees Celsius. That's what? 20 degrees Celsius. So we're going to have 20 degrees Celsius here. So let's kind of solve everything here. So we have L2, we have 10 meter plus. So when you press the calculator in all this, you should have something like this. Okay, I think we should do it together. Let's do this together so you won't be surprised. So converting this one to fraction, we have something like this: 17 over 1, 2, 3, 4, 5, 6 times the power of 6 multiplied by 200. So this will be what? 4. When we cancel this will be 4. Do you understand this? Let me explain this. We convert this to fraction as 17 over 1, 2, 3, 4, 5, 6 multiplied by 10 multiplied by 20. 1, 2. So what do we mean? We have 17 multiplied by 2, that's 34. So we have L2 is 10 meter plus 34 over 1, 2, 3, 4. 1, 2, 3, 4. So when you divide this, we have L2 is 10 meter plus 0.1234. So meter, we have it. So for that, we come to the end of this video. We'll continue the next one in the next video. Thank you so much. I really appreciate it.